Hello, my fellow mathematician, wherever you are. This is Calculus 2, integration by substitution of trigonometric function. So we want to integrate square root of x squared minus 1 divided by x squared dx. We are going to let our x to be equal to sec theta, meaning that dx is equal to sec theta, tan theta, and d theta. When we differentiate this, x squared will give you sec squared theta. Now, we are going not to use this identity, which tells us that 1 plus tan squared theta is equal to sec squared theta, meaning that our tan theta squared is equal to sec squared minus 1. So we substitute here where you have x squared with the sec squared theta minus 1. From here, it means the square root of tan squared theta, which is equal to tan theta. Then we are going to make the substitution there. Instead of square root of x squared theta minus 1, we are going to substitute it with the tan theta from this simplification. So you have tan theta multiplied by, instead of dx, we are going to substitute our dx with the sec theta tan of theta d theta. We divide by our x. We have let our x to be equal to sec theta. So we have x squared, meaning that we are going to have sec squared theta. This will simplify to, you have tan squared theta divided by sec theta. But note the following, we are going to use this, but tan theta is equal to sine theta over cos theta. Also 1 over sec theta. 1 over sec theta is equal to cos of theta. Substitution where you have tan theta. So this is the integral, which is equal to sine theta squared divided by cos theta squared multiplied by cos theta d theta integral, which is equal to sine theta squared over cos theta d theta. One of the cos here will cancel. This can be written as sine theta multiplied by sine theta divided by cos of theta integral. Now, our tan theta is sine theta over cos theta. So this is d theta. This can be written as tan theta sine theta d theta. So we have our equation now as tan theta sine theta d theta. We are going to integrate this by part. So we are going to let our u to be equal to tan of theta, meaning that our du is equal to sec squared theta d theta. Then we let our dv be equal to sine theta d theta. This part here. So integrate both signs. Integral of the derivative of v is v. Integral of sin theta is negative cos theta plus constant. Integral of u dv is equal to uv minus integral of v du. So we substitute, so we have our integral of tan theta sine of theta d theta is equal to, our u is tan theta, our v is minus cos theta minus integral minus, which is equal to tan theta. This is minus cos of theta plus integral of cos theta multiplied by 1 over. So from here, plus, instead of sec squared theta, we can split it as 1 over cos theta integral of that. So cos and the cos will cancel. So that now we are going to have negative tan theta cos of theta plus integral of sec of theta d theta, which is equal to negative tan theta cos of theta plus natural logarithm of sec of theta plus tan of theta plus a constant c. So we and let our x be equal to sec of theta, and the sec of theta is given by hypotenuse over adjacent. So meaning that we can draw a triangle of hypotenuse x and adjacent one, meaning that our right. So from that diagram, our tan theta is the same as square root of x squared minus 1. Our cos is adjacent of hypotenuse, which is equal to, so this is times 1 over x plus natural logarithm of sec theta in terms of x is the same as x here, is the same as x plus tan theta, which is square root of x squared minus 1 modulus plus c, meaning that our integral of square root of x squared minus 1 divided by x squared dx is the same as natural logarithm of x plus square root of x squared minus 1 modulus minus this part here, minus square root of x squared minus 1 divided by x. So that is how you get the integral by substituting the trigonometric function. Thanks so much guys for taking time to study with me. I want to recap this working so that you may get the concept. So first of all, you let x to be sec theta, meaning that dx will be sec theta tan theta d theta. x squared will give you x squared theta. Then you are going to use this identity which says that 1 plus tan squared theta is equal to sec squared theta, meaning that tan squared theta is equal to sec squared theta minus 1. So where you have x squared, you substitute with the sec squared theta here, minus 1. Then that is the same as tan squared theta. So we take square root of tan squared theta to get tan theta. Then you substitute in this equation, where you have square root of x squared minus 1, you substitute it with the tan theta, multiplying by sec theta, multiplying by tan theta d theta, divided by sec squared theta. So one of the sec will cancel there, and you are going to have tan times tan theta to get tan squared theta divided by sec theta. Because 1 over sec theta is the same as cos theta. Then from there, you can see 1 of the cos will cancel, and we are going to be left with the sin squared theta over cos theta. We can split so that you can have sin theta divided by cos theta times sin theta d theta. So from here now, we integrate this by part by letting our u to be tan theta, meaning that the du is sec squared theta. Then dv is equal to sin theta d theta, this part. Then we integrate. After integrating, we are going to get negative cos theta plus c. Then we substitute in this formula. Our u is tan theta, our u is negative, our v is negative cos theta, and our u is tan theta. Integral of negative, our v is cos theta, our du is sec squared theta. Now, sec theta, 1 of the sec theta can be written as 1 over cos theta multiplied by sec theta, as shown here. So cos and the cos will cancel to be left with the sec theta d theta. Then from here, the integral of sec theta is the same as natural logarithm of sec theta plus tan theta, as shown there. Then from there, what we have done, we have used this right angle triangle, whereby sec theta is given by hypotenuse over adjacent. So we can get the opposite by Pythagoras theorem, and then we have replaced here to obtain our result as shown here. This is plus a constant c, c. So thanks so much, guys, for studying with me. For more video tutorials like this, remember to subscribe to the channel and also to click on the notification bell so that you won't miss a single video which I upload for you every day, guys. Bye bye, and thanks for your continued support.